Hello and welcome to this presentation of the new FEM analysis module in Tremuri. So to present this new module, it's very important first of all to make a difference of what is the FEM approach to the static verification of structures. As we see here, the FEA or finite element analysis tab, it's going to be a new environment that it's going to work along with the one that already existed in Tremuri, which is the frame by macro element analysis. So now Tremuri software presents two different approaches, the equivalent frame approach and the new FEA approach, which is a finite element analysis. A finite element analysis is a very common type of analysis, type of approach in mechanical engineering, and in this case it's going to be applied to the static verification of a structure. So now, because we are going to have two different approaches working together, this now expands what Tremuri can do with the calculation of structures and with the types of structures that Tremuri can calculate. So in many cases, we're going to be presented with the choice to which method to choose to analyze our structure. Of course, the two different approaches have different advantages and disadvantages. The frame by macro element is, of course, our classical approach, and the FEM analysis is going to present several advantages, but usually because it's going to take a bit more calculation time, it's going to represent a compromise. So how to choose between the equivalent frame approach and the FEM approach? We are going to use the equivalent frame approach when we have an uniform distribution of openings in the various walls and along the heights, a limited presence of walls without openings, and in the cases that we want fast and immediate calculation. On the other hand, for the FEM approach, we are going to use it, or it's going to come very handy, it's going to be very useful in the case of highly irregular distributions of openings along walls and height, significant presence of walls that don't have any openings, and for example, when I wish to examine more precisely the distribution of floor loads in the masonry, but this is accepting longer calculation times. And of course, I am willing to go into detailed verifications of various masonry piers in order to optimize the verification as closely as possible to reality. So, as we see here in this presentation, the FEA analysis module, it's going to present me with a 3D view of the structure, and it's going to give me the option to calculate a mesh, which is going to divide the 1D elements into segments and the 2D elements into small and manageable triangles or shell elements. And it's going to make the verification for each one of those segments or mesh elements. So as we see here, we have new icons to perform this type of analysis. First of all, we have a configuration that we can define the size of the mesh for 1D and 2D elements. We can perform the mesh calculation. As we see here, this is already done, and it's going to perform that type of grid that it's going to be more refined or with bigger size of shell elements as we want it to be. And once we do that, we can just go ahead and perform our static calculation. The static calculation, it's going to be performed on the present state of the mesh. Of course, we have different options to make our mesh more precise or more to imitate more the reality. And for example, one of those functions is to refine the mesh in certain points that we want to have more information. As we see here, once the calculation is done, we are going to be able to see the results. What Tremuri is going to do, it's going to present us with the results of different limit states and different combinations of loads. And the results are going to be presented in several ways. We are going to be able to see the deformed shape of the structure. That's going to give us a very precise shape of the structure. And also we are going to be able to see, as we see here once we enter the results environment, as I previously said, we have different combinations at different limit states, and we are going to be able to see the displacements of the structure. As we see here in our 3D view, we are going to be able to see the displacements for 1D and 2D elements, displacements, internal forces for 1D elements, that they are going to be presented as a graph, as we see here, and for different types of forces and stresses, as we see here, shear, axial forces, so we see here shear, also bending moment on the Y and Z axis, as we see here. And of course, if we want to see with more detail our structure, we can always go and change the view for an elevation view. So we see here, we can see it in more detail, and we can have here the graph. Of course, we are going to also have the internal forces for to the elements, which are going to be represented with a color map that we can open the scale and select the internal forces that we want to show to give us a more detailed aspect of what's going on inside our masonry pier. And also the stresses, which are available for 2D elements, also represented with a color map, and the reactions in different directions. For example, if we want to see the Z direction of the forces, we can just go ahead, and once we hover our mouse over a single force, we can see its value. Another option is to generate the piers, that this can be made in automatically or manually. If we want to generate automatically, we just click on the icon and they're going to be generated very quickly, as we see here. Or if we change into an elevation view, we can just generate them automatically with our mouse. And of course we can add them, modify them, and delete them. Of course we can do the same with right clicking, and we can modify them. We can change the definitions of the top, middle, and bottom section, which are going to impact on the results that we saw earlier. We can change our reduction coefficients, and because these are not yet calculated, we cannot see the results. But as soon as we go to the results section, we're going to see a new option because we generated the masonry piers. That is the static analysis. It's going to provide us with a color, so we can very quickly know if masonry pier is verified or not, has passed the verification. And we can go into the results details, select any masonry piers that we want, and we can see its results in eccentricity and the relation between ND and R. That, of course, if it's lower than 1, it's going to be verified. And we can see the max value or the value at the top or the middle or the bottom of the section. So we see here. Also, of course, we can see the more detail of the pier that we selected in this area over here, such as the height, the width, the thickness, the effective T, the rho N, rho T factors, and if we want, of course, we also can see the eccentricity. And of course, if we want, we can go into the stress details for every single masonry pier and watch how the results are going to be performed on that specific pier. As we see here, we can also change the definitions of top, middle, bottom, as we saw earlier, to update the results, because in some cases we want to analyze a particular height of the masonry pier because of the singularity that our structure has. So as we see here, we can have the internal forces such as axial and bending moment of two different heights, and we can see the color map that's going to show us our results, and of course we can see our numbers here in more detail.